Hello and welcome. We are glad you have joined us. My name is Amit New. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. This is the second part of the module Design a Compute Solution. In the first session, we covered how to choose a compute service, design for Azure virtual machines, design for Azure batch solutions, and design for app services. In this session, we will focus on design for container instances, design for Azure Kubernetes Services, and design for Azure Functions and Azure Logic Apps. Let's continue building great solutions. Our first topic is how to design for Azure Container Instances solutions. We've all debugged an issue that only showed up in production. Containers reduce that gap by packaging the app and everything that it needs so production behaves like your laptop, not like a surprise. Azure Container Instances is the simplest and fastest way to run a container in Azure. No VM management, no orchestrator required. Let's say we have a nightly job that runs for 90 seconds, write an output to a storage, then stops. With virtual machines, we're paying compute power by the minute. In containers, in seconds. That's where Azure Container Instances shine. Fast start, low cost, no leftovers. Monitoring isn't just a checkbox. It's essential for both managing your solution and keeping it secure. Think of it as your ongoing safety net, not just to launch, but throughout your container entire journey. Start with a container registry. Make sure you've set up image scanning to catch up any issues early and prevent harmful code from slipping through. Once your container is running, stay curious how it is actually being used. Are there any unusual resource spike or unexpected activity? Regular vulnerability assessment and active monitoring help you spot the problems before they become real headaches. Keep your containers and your data safe and sound. Think of Azure Container Instances as containers on demand. You supply a container image and Azure runs it for you almost instantly. There is no infrastructure to set up or maintain, which makes Azure Container Instances especially attractive for developers and architects who want simplicity and speed. It's quick, easy, great for testing, short-term processes, and even burst scenarios. It is ideal when you just need something to run now, and it's also great for isolation. For example, we would like to use the Azure AI service for language, but we can't afford to send sensitive text into a public endpoint. Instead of moving our data, we will move the service. We can run the Azure AI language service in a container in our own Azure Container Instance, even inside our own network. The container will process the data locally where we have configured it, while only the usage metrics are sent back into Azure for billing. That gives us isolation, control, data residency for compliance regulation. Keep in mind, once we need orchestration features like rolling updates or service discovery, ACI stops being the right tool for you. That's where Azure Kubernetes Service or Azure Containerized Apps come in. We recommend containers when we want portability and fast release cycle. They offer lightweight isolation and allow you to deploy updates quickly, making them a great fit for agile development teams. For example, a development team building several small services can package each one as a Docker container and deploy them quickly with minimal overhead, sharing the same underlying operating system while keeping each app logically isolated. They can even increase the security by using Hyper-V level isolation. Virtual machines, on the other hand, provide a full operating system environment and much stronger isolation boundary. VMs are recommended when we require robust security, need full control over the OS, or we are working with legacy applications that expect a dedicated server environment. A container is an isolated, lightweight silo for running an application on the host operating system. Containers build on top of the host operating system and contain only the apps and some lightweight operating system APIs and services that run in a user mode, as shown in this diagram. In contrast to containers, virtual machines run a complete operating system, including its own kernel, as shown in this diagram. Once your containers stop being single runs and start becoming a system, orchestration matters. That's where Azure Kubernetes Service comes in. When you need to run many containers together, keep them healthy, roll out updates safely, and let the platform handle the choreography. If your app is 20 services that must scale and deploy independently, AKS start to make a lot of sense. Instead of manually running individual containers, Azure Kubernetes Service acts like a smart conductor, automatically starting containers, restarting them if they fail, and scale them up and down as the demand changes. Azure takes care of the Kubernetes resources behind the scenes, things like cluster setup, node upgrade, and health monitoring, so teams can focus on building and running their application rather than maintaining the platform itself. A good approach is to plan your strategy from 2 points of view. Consider the features from the approach of a new project and also from the perspective of migration. Who manages what and what we are paying for? Well, Azure manages the Kubernetes cluster for free. You manage the agent nodes in the cluster and only pay for the VM's power which you use for your nodes. How do we scale? In Azure Kubernetes Service, it is designed for 2 layers of a scale, application layer and infrastructure layer. You choose the triggers. It can be CPU, memory, request rates, whatever matches your workloads. How do we isolate the workloads? Well, we can isolate by node pools and design boundaries, so one noisy workload doesn't hurt everything else. What about other security considerations? Integrate Entra ID to improve authentication and authorization security. Use Azure Monitor for performance visibility and container insights. Design a clean ingress approach. For example, using a private registry is highly recommended. Leverage Defender for Cloud for Containers to maintain ongoing protection from end to end. Azure Kubernetes Service is a platform-managed orchestration with customer-owned runtime design. Choosing AKS means you're accepting ownership of node pools, scaling strategy, security boundaries, cost visibility in exchange for flexibility and cloud-native scale. Azure Kubernetes Service supports scaling across regions, which is important for a global application. It takes the advantage of the Azure paired regions to improve disaster recovery planning. Also, storage can be synchronized using either infrastructure-based replication or application-level replication, giving architects the flexibility depending on how critical the data is. A good real-life example is a global app. Users in different regions continue working smoothly even if one region has an outage, and the system quietly redirects the traffic, keeps services online, exactly the kind of resiliency modern production workload needs. We can plan for multi-region deployment in an active-active, active-passive, or passive code mode. Let's check out a real solution from our customers at Mercedes-Benz: container-driven cars. This concept refers to microservices-based architecture that relies on containers to fetch and push up updates at scale all over the IoT environment. But connected cars are no joke. That software that assists driver to automate tasks require precision engineering. Using cloud-native services on Azure, the R&D team freed developers from limitation of a hardware-driven release cycles, where software updates could only happen once or twice a year. Today, developers can create new versions as fast as they want and ship new solutions to the market in just 3 months, thanks to a mix of agile tools and managed services on Azure for Kubernetes, API, and databases. The container-based car service is designed to begin working when a driver starts their car. The head unit sends a request using the vehicle SIM card to connect to the service across mobile network. Azure Kubernetes Service handles the backend operation, which supports 2 platforms for containerized app creation and for the other app configuration and delivery to the vehicles. The AKS cluster runs the following key services. First, the orchestration service is the containerized platform at the head of the unit. The source code repository service that is an abstractive of the Git repo providers. The continuous integration service acts as the pipeline management system by abstracting the CI/CD providers and establishing the app's initial pipelines. The feature configuration service abstracts the tools that provide feature toggling and that are used to provision the project and resources for a new head unit app. API calls are routed into the backend services through the Azure Kubernetes Service. From the application creation side, the application gets built as a container image. That image is pushed to the private registry. The application metadata and configuration details, including deployment specs and the Kubernetes-like pod specification, are pushed into Azure Cosmos DB and made available for use in future testing. The other paths support app configuration and delivery to the vehicles. To minimize the latency, all requests are updated and routed through the Azure Traffic Manager to the closest AKS cluster. A head unit orchestration agent compares an update request to the versions already owned by the driver, pulls the correct image from the closest registry, and sends it back to the car. In the data layer, Azure Cosmos DB plays a key role and provides the geo-redundancy needed for high availability and low latency reads and writes worldwide. Other services depend on the metadata and config details that are stored in the Azure Cosmos DB. The most critical operations are rate-intensive, and the team set up multiple fault-tolerance strategies, including active-passive model based on geo-redundancy. The duration of the entire round trip varies depending on the type of app, size of the image, and other variables, but it ranges from few seconds into few minutes. The team also met the success metrics established as the Project 2 goals to build a fully functional prototype in 24 hours and to ship a new solution to the market in just 3 months. Now we move into serverless-based solution. Code first. Yes, you guessed correctly, designed for Azure Functions. Azure Functions is a compute on demand. You write a small unit of a code that runs on a trigger. It's perfect for app messaging, responding to events, or following a schedule. Azure allocates compute power for you and then release it. It supports microservices patterns, code reuse, and scales easily, especially suitable for event-driven workloads, like a blob uploads that trigger a function to process the file and write its metadata. We recommend using Azure Functions when you need event-driven, code-based logic, lightweight APIs, automation, or glue code between services. To ensure reliability and efficiency, avoid long-running functions unless you're using durable functions for orchestration. It is best to organize the functions for performance and scaling and straighten your code by writing defensive code, retries, error handling, and good monitoring. If the function runs on every event, one bad error path can create a storm. Defensive coding prevents that. Azure Functions is an ideal solution for handling specific definable actions triggered by an event. For an example, a function can process an API call and store the process data in Azure Cosmos DB. After the data transfer happens, another function can trigger a notification. Up next, serverless, but designer first. Designed for Azure Logic App solutions. Logic Apps is a workflow automation platform for integration. If your problem is connect system and automate a process, Logic App is a strong first option for you. With Azure Logic Apps, you can quickly develop highly scalable integration solution for your enterprise and B2B scenarios with no-code, low-code approach. It includes over 1,400 pre-built connectors that you can use to integrate your workflow with various services, systems, apps, and data. SOC automation is a common pattern and highly in use. Detect something, run a workflow, notify, and take action. We recommend Logic Apps when we want low-code orchestration with built-in connectors and we don't need sub-millisecond response time. This decision tree is here to help us make the structured, informed decision. When we would like to choose an event-driven architecture, it is important to clarify how our logic being implemented, design or code. The key takeaway is that Logic App shine with orchestration, integration, and visibility when those are the priorities, while durable functions are better for developers that want to stay fully in code mode. In practice, teams typically combine both services, Logic App to manage workflows and integration, and rely on functions for specialized or complex tasks, for instance. Logic App might coordinate approval process and send notification, while the function handle custom business logic. That combination is very common and very effective. Let's see a common enterprise integration workflow. The application is a client that calls the API gateway after authenticating with Microsoft Entra ID. The application can be a web application, mobile app, or any other client that can make HTTP-based requests. Microsoft Entra ID is used to authenticate the client to the application. The client application obtains an access token from Entra ID, and it includes it in the request to the API gateway. The Azure API management consists of two related components. The API gateway. This is accepting our HTTP calls from the client application, validate the token from Microsoft Entra ID, and forward the request to the backend service. API Gateway can also transform requests and responses, cache responses as well. The developer portal is used by developers to discover and interact with the APIs. The developer portal can be customized to match your organizational branding. The Azure Logic Apps are used to orchestrate the calls to the backend services. It can be triggered by various events and call various services. In this situation, Logic App is used to call the backend service and provide connectivity through connectors, reducing the need for custom code. The backend services may be any service or line of business application, such as databases, web service, SaaS application. It can be hosted on Azure or on-premises. Time to review what we have learned. Let's go back into our use case from part 1. Let's rethink about the solution. How can it be optimized? Can we save costs with serverless-based solutions? Pause and think. Maybe you have a similar problem. What are your current investments? What knowledge do you have in your organization? That can lead to a different solution. So, how can we optimize this solution? Let's first define our front end, our middle tier, and the back end. Maybe we can use SQL PaaS services for the back end. What about our front end? This can be hosted in a web app. It's a perfect fit for IaaS in a managed web environment. What about our middle tier? This is just code handling API calls. Azure Function can replicate the functionality in a cloud-native, cost-effective way. If durability needed, host it on a dedicated plan. It can communicate directly with our backend. Consider VNet or centralized hub for the load balancer. Layer 7 with WAF to protect against web application vulnerabilities like cross-site scripting. That works well with App Gateway. We can even deploy this orchestration as hardened access with private endpoints for the front end, the middle tier, and the back end. What about some use cases? Let's try to match the products on the left with the use case on the right. What are virtual machines good for? Those provide you full operating system access. What about our app services? This is a great fit for mobile apps. What about container instances? With them, you can move your independent Docker containers to PaaS offering. Azure Kubernetes Service. This matches for container orchestration. Azure Functions. This is great for scheduled tasks and messages. And last one, Azure Logic Apps. That's a perfect fit for workload triggered by an event. In this session, we have covered design for Azure Container Instances solutions, design for Azure Kubernetes Services solutions, design for Azure Functions, design for Azure Logic Apps. This concludes our model for design a compute solution. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. I'm Amit Nair. Thank you for watching and happy learning.